Hey guys, I will answer a question from Giancoli's textbook. This is problem 37 from chapter 11, which asks you to calculate the speed of longitudinal waves in water, granite, and steel. Okay? So for this problem, you'll really need to refer to section 11.8 or 11-8, and in there, you will find the two equations that you will need for this to solve this problem. Okay, the first one is v equals square root of b over rho. This is relating the speed of the wave, the elasticity E, or elastic module, and elastic modulus, and rho, which is the density. Okay. Very similarly, there's another equation, which is v equals square root of b over rho. In this case, b is the bulk modulus. Okay, and so these are equations. These are equations that are in section 11-8 in the book, and they're equations 11-14a and 11-14b, I believe. Okay, so let's call these equations 1 and 2. Okay, so so 1 and 2. So this is for, so 1 is for granite and steel. Okay, and 2 is for water, because this top equation over here is actually only for waves, longitudinal waves propagating in a solid, which granite and steel both are. And this equation here is for those waves traveling through a liquid or a gas. Water is a liquid, so this is the equation that applies. Okay, and so what we have to do now is refer to two tables from the book. Table 9-1, which gives you the bulk modulus B and the elastic modulus E for a variety of substances, including water and granite and steel, and table 10-1, which gives the densities of these substances. Okay, and so we find that, let's start with water because that's part A of the problem. For water, subscripted with H2O, which is the chemical symbol of water, the speed of longitudinal waves moving through water is equal to bulk modulus B over density rho, which is equal to, from those tables in the book, the bulk modulus is, sorry, that was not 9, that's a 2 times 10 to the 9 newtons per square meters. Units are very important, and remember that Newton has SI units, which is to say kilograms, meters, and seconds in it. So we're good there. You divide that by density. In SI units, that's 1 times 10 to the 3, or 1,000. Okay, kilograms per cubic meters. And so Newton has units of kilograms meter kilograms meter per second squared, and so that cancels out, a bunch of things cancel out, and what you get here is 1414 meters per second. Okay, so that's for water. For granite, you do the same thing, VGR to denote granite. You do the same thing except you're looking for E, which is the elastic modulus. Rho is still the density. And so from those tables, 9-1 and 10-1, we have for granite 45 times 10 to the 9 newtons per square meters over its density, which is 2,700 kilograms per cubic meters. Okay, and that gives you something close to 4,082, kilogram, 4,082. This is the speed, so it'll be units of length over time, in this case, meters per second. Okay, and finally, you have for steel, ST to denote steel, the same thing, elastic modulus over, so sorry for that, over density, and we find that those from the tables, and you get 200 times 10 to the 9 Newton per square meters divided by the density of steel, which is 7,800 kilograms per cubic meter. Notice that steel is much denser than water and even granite, which makes sense. It's a good thing to check for these things, right? Common sense check. And you put that in the calculator and you get something very close to 5,070 meters per second. Okay, and so there you have it. The final answers you can write as 1410 for water, 4,100 for granite, just put WG, and 5,100 for steel. All right, that's it.